Hello and welcome. So last time we finished up the debug type information, and so this time I want to start tackling the debug symbol information and debug line information. Both of them are sort of bundled in the same thing. So essentially how this works is that each of these object files has one of these debug S sections, and then we have to sort of process and copy them into a module symbol stream for each of them. So a compilation unit is called a module in the PDB format, linguistic or whatever. And well, the debug type information was already sort of annoying and whatever, but this is going to be way more annoying. All right, but it all starts by looking at the so-called DBI stream or debug information stream. And as I already tell here, it's one of the most complicated streams defined in the PDB format. And essentially the way it works is, well, it has a bunch of fields, and afterwards there are a bunch of substreams. And each of these substreams, again, has its own small layout. Okay, but importantly, there's almost, well, today we're only going to fill out probably this stream and nothing else. But importantly, what it does, it defines the modules, so the compilation unit links to all of those, and defines their module symbol stream where it is, which for us is going to be this module symbol stream base plus the index of the module. And then it also links to the global symbol stream, the global index stream, the public symbol index stream, and well, the symbol record stream somewhere. Yeah, here, symbol record stream. And lastly, also later on, it maps to this section header dump stream. So essentially, once we filled in the DBI stream completely, we can move this PDB current amount of streams to the very end, meaning we are done with this variable. But for today, I'm just going to pretty much say all of these symbol indices are going to be -1. So stream not defined, essentially. And we're only going to fill out this DBI stream header. So we don't actually have to deal with these debug S sections yet, which is somewhat good because these debug S sections also require us to apply some relocations. Namely, there is the image rel AMD segrel relocation that is often used, this is used to support debug information, and the image rel AMD 64 section, which is also used to support debug information. Okay, but we don't have to deal with that today. Today, I just want to start filling in the debug information stream and yeah, start on that. So let's do that. So in the right PDB code where we are already here, I'm just going to go to the write PDB function, which does the actual writing of the PDB, and the very end here. So this is the TPI stream and IPI stream that we dealt with the last couple of videos. And now here I'm just going to make a struct memory arena as we have been. Arena, and this is the DBI stream. Create memory arena of 8 gigabytes. I think I've been doing. Yes. And then I think I'm keeping this comment around of like fill out the whatever stream. So let's keep that one as well, even though it's kind of useless. Fill out the DBI stream. Okay. Just to give it some space. And the DBI stream starts with the following header. So let's copy this boy. DBI stream header. Push struct, and so we add that to the front of the DBI stream. Okay, first field, version signature. This value has to be -1. This exists because there was an earlier version of the stream which did not include a versioned header. Version signature is -1. The signature version is 1999 09 03. Four years younger than me. The age is I think every age for us is just 1, so we assume all of this has been written one time. So the age of the DBI stream gets set to the age of the PDB whenever the DBI stream is written. Okay. Stream index of the global symbol stream index is global symbol index stream, and so on. All of these stream indices are going to be -1 for now. This is U16 -1. Which means that the stream is not present. I'm not 100% sure if this is legal, but I'm just gonna keep it that way, and I don't know if my validation utility will complain. We'll see. For the stream, see you later seconds. Okay. These streams indices can technically be -1, meaning that they are not present, but they are seemingly always present, I say here. Okay. Toolchain version number of MS-PDB DLL, which built the PDB. Okay, I did really go overboard with these names, but whatever. Build number of the MS-PDB DLL, which built the PDB. And apparently I say here, the node warning maybe one that this is being used. Clean up, what did I think? Some Clang comment said that this was being used apparently. The version number of the MS-PDB XXX DLL, which built or rebuilt this PDB last. These four version numbers together make up the product version, which can be seen in the properties dialog of MS-PDB XXX DLL. Looks like something 14, 29. Okay. So let's copy these. I assume the 0 is ignored. Oh no, toolchain has 2 versions. And I don't talk about is new version format, but that's probably one. But yeah, there are already some notes and cleanups in there, so I will have to fix that up before I release this. Okay, but I'm just going to say toolchain version major version is probably this 14. The minor version is probably this 29. The is new format version, is new version format I assume is 1. Just going off of what this is. And then there is the version number and the build number. I guess I'm assuming that the version number is the bigger one and the build number is 0 in this case. And let's put the isNew format first. Add cleanup, select these. I don't think they matter for us right now. Byte size of the star substream. Immediately following the header, there's a variety of substreams, one after the other. For more information on them, see their respective subsections. Notice the non-linear order of the members. Yeah, so it's 0, 1, 2, 3, 4, 6, 5, and there's some weird index in the middle. Index of the MFC type server in the type server map substream. In the released version of MS PDB core, the PDB type server defined is not defined, which means this is always 0. Okay. Flags was linked incrementally is set when an incremental linking table is present, which is not for us. Private symbols were stripped is set when PDB copy utility was used to remove private symbols, also not our case. And allow conflicting types flag is set when the PDB was created with the undocumented DeBug C types linker flag. Here I'm not actually sure if we are abiding by this, so because we just put all of the types in there. So maybe in theory we allow conflict types, but I'm not gonna set that flag. Whatever. Let's maybe make a comment about this. Should we set flags dot the PDB allows conflicting types? Okay, machine type, an identifier that's an identifier for the target processor. See the CV CPU type E inside CV const or this MSDN link. And here is also missing that this is actually used for CV dump. But whatever. We care about it being x64, I guess, AMD 64, which is apparently D0. DBI stream machine type is this value right here, which is OXD0. Then reserved padding. So, alright, DBI stream header probably filled in somewhat correctly. We have to fill in these substreams now and then set their values. The module information substream. Immediately after the DBI header, there is the module information substream. It consists of an array of variable length module structures. The index into this array determines the module index, which is referenced by other information later on, well, to talk about the module. Each module structure has the following layout. So we have one of this boy. PDB module information. What would this be? I guess we have to do this in a loop. So for U32 index, let's say object file index is 0, object file index is smaller than the PDB write information, write PDB information, object file, amount of object files, object file index plus plus. We push on one of these PDB module information things. Information is push struct. Let's see how this works out with alignment, but it's probably fine. Oh, we also have to define the section contribution, I guess. But anyway, into the DBI stream, one of these PDB module informations. Unused, blah. First, code contribution. A copy of the first entry in the section contribution substream, see below, for which this module, which has the section contains code characteristic set. If this module does not contribute to the code of the executable, this entry can be the invalid section contribution, which has section ID, size, module index of -1, everything else 0. First of all, let's scroll a little bit further down and get the PDB section contribution thing. Be like right here, maybe. See how that looks. And then we probably want to be able to reference these PDB module information structures, pointer to these from later on. So let's maybe copy this type out and put it here. And we can use this PDB section information contribution thing right here and define it in line. And I'm going to say a pointer to a pointer is the module information per module, I guess, which is push struct. And here we don't want to use the DBI arena because, well, this isn't part of the stream. So I'm just going to use arena, which is our trash arena, I guess. Scratch arena, maybe. And there I want to push a pointer, an array of pointers to PDB module informations for, I guess, the amount of object files, but there's also the special linker module, but maybe I don't do it like this. So let's say per compilation unit, per object file. Okay. And so then we have one of these PDB module information structures for each object files. We assign it to the array. So we can reference it later on. And then we fill it in. And I did that because, well, at first I will put this first code contribution to the invalid module section contribution. And later on, when we fill in the section contributions, I will notice the first one, I think, is what I will do. So the first code contribution. Where does the S come from? Anyway, first code contribution is a struct PDB section contribution, which has, this tells me section ID, size, and module index of -1. Here, for some reason, I have signed types. Everywhere else I was using unsigned types. But whatever. Okay. Was written. This is false. Maybe. Or true. Maybe it doesn't care about it. The was written flag. Edit and continue enabled is set when the object file was built with the ZI flag, which I guess it's not true for us. TSM index is 0. And then I guess that is it for the flags. Stream index of the module symbol stream. This for now is also going to be -1. Later on we have to fill in all of these module symbol streams. Byte size of the symbol information, byte size of the C11 line information, byte size of the C13 line information. This is what we have to fill in later on when we have actually emit the symbols, module symbol streams, but for now, because I set the symbol stream index to -1, all of these are going to be 0. And actually, let's explicitly set them to 0. And put an incomplete in front of them. Also amount of object source files. Then the edit and continue source file string index and edit and continue PDB file string index. These are, I think, only for the linker module, but let's see. The amount of source files which contributed to this module. Oh no, that's for the amount of source file. Edit and continue source file string index. Edit and continue PDB file string index. If these are set, they are offsets into the edit and continue substring string buffer. The edit and continue source file string index is sometimes set by masm for .asm files, like memcopy.asm. The edit and continue PDB file string index only seems to be set for the special linker module. It has this field set to point to the full path of the PDB. Okay. But maybe we don't have to care about that, we will see. Module name and file name. This member makes the struct PDB module information variable sized. First, there's a 0 terminated string to the module name, then there's a 0 terminated string to the file name. The module name is simply the, if the module is a simple object file, then both strings are just the full path to the object file. If the object file is part of an archive library .lib, then the file name is the full path to the archive file, and the module name is the name of the object. Okay. Note that the module name in this case is the module specified in the archive, which can also be a full path. For Microsoft Archives, module name is some giant thing, and the file name is libctm.lib, for example. Okay, so we need to know for the currently we only have object files, because for the lib files we only use that they are import libraries for now. Not sure how this is going to behave later on, but for now I don't think we have modules that don't come from object files. So what I'm going to do is just put them both to be the same, which are passed in, which I will pass in through the write PDB information again. And maybe what I'm actually going to do, because this has already one field that is per object, I'm just going to make a struct write PDB information per object information, maybe, and this per object. One contains the type information. But then also contains, what were we talking about? The object file path. I'll just call it file path. And then where we are passing this in, so in, let's maybe go here, linker, write PDB information. Instead of allocating a stream star, I'm going to allocate one of these write PDB per object information per object. And then for object type information is assigned here. And per object is per object. Then we have here it's per object of the object file index and type information. DBI stream. Oh, DBI stream header. That's what I need here. Okay. Stream index of the public symbol, the public index stream, public symbol index stream. So there's a bug in the documentation somewhere. Here, the DBI stream. Public symbol index, yeah. So let's fix that real quick. PDB documentation, the README. I want to search for maybe this. Public symbol index stream. Okay. Stream index of the symbol record stream. That seems correct. Stream index of the symbol record stream. Isn't that what this was called? Oh, there's a D missing. Of symbol. Okay, let's recompile, get there. Of the. Okay. Back to actually doing stuff. I now sort of have the file name, but not quite, because I haven't filled it in yet. So in the linker, per object, let's say, then this per object of the object file index file name is object file name. And then it told me I had to copy that one out twice. So let's do that. But how do I do that the best? Don't have a way to push on a seed string. So I guess we have to do a strlen of I guess write PDB information per object file index file name. Let's get that one out into its own variable, so char star object file name. It's disputable boy, and then the size size is the strlen of the object file name +1 for the 0 terminator. And so we push push array into the DBI stream of U8s or chars, I guess, of the size. Sure, it's local enough, I guess. Remem copy in the object file name. Then we do the same thing another time. And let's say module name and object name or something. And this should probably be this should be the module substream. So I think what it's called, module information substream. So let's do U8 module information substream start is arena current. So where we are currently in the DBI stream. Then in the end, we can calculate the size. Which is, again, just the current minus the start. Let's put a little indentation on it so it's more clear, and the comment module information substream. And then we need to fill in the field in the DBI header, which was the byte size of the module information substream. Okay. Substream number one. God damn it. German brain took over. Wait, there is the last special linker module left. So, okay, special linker module. The last module is the special linker module, which works exactly like any other module, only that its symbol record stream contains special symbols which contain information about stuff the linker added. The first section contribution tells you where to find the incremental linking table. The edit and continue PDB file string index is also an index into the edit and continue stream to the full path of the PDB. Also, the module symbol stream of the linker module contains special symbols like S sections, for example. So here I'm also gonna have one of these PDB module information pointers being the linker module. Then the linker module works the same, is just a push struct, one of these PDB module information structures. We fill in it exactly the same for the most part. So the first code contribution. Should I copy this? Yeah, sure. Let's copy all of it for now. And it's linker like this. I don't talk about it here, but I call it linker like this because I think that's its name, but I should add information about that. Talk about the object name being linker in the readme, I guess. Okay, but I think I'm just going to say char star object file name is this string linker. And then I think I only have to copy it once. And afterwards, I'm just going to push. Well, I'm going to push size +1. I think that's correct. How would I test that? I think, do I have any good one here? Yeah, so this was produced by MSVC. So I can do cv dump in this. And then we should see module linker from blah. Modules. Nothing linker. It's not too clear to me. Does my validation utility say anything? It's not called validation. Validate, probably. Okay, module name, linker, object file name, nothing. Okay. So what I said there is correct. Right, PDB. And then this is not module information, but linker module. Next one, section contribution substream. And this one could be a little bit annoying. So essentially, the section contribution substream contains information on how to map offsets in the executable to module indices. It begins after the module information substream and starts with a U32 version followed by an array of either PDB section contribution or section contribution v2, which also has a segment ID in the object file, which this bigger structure is only for fast link PDBs, if you heard of that. So we don't have to care about that, I think. But so essentially we have to provide these PDB section contributions. And essentially how this works is that there is one per section that made it from an object file into the executable. So we also have to gather these while compiling, I think is how it's going to work, while linking. But so, okay. Let's for now push. Are these? Do I have alignments? I don't think I have alignments. So, do I talk about this here? Doesn't seem, so I guess we're not aligned anymore, but there is no warning. Let's look into validate, into the module substream. module substream, module information, pass the module information substream. This is everything here is already passing the thing. The module symbol stream. Align the stream. Module information substream offset plus equals 3 and not 3. So we need to talk about the alignment here. Okay. So going back to the write PDB stuff. Here, whenever we are emitting one of these modules, align on a 4-byte boundary. And is there a push align? I guess I can just do push. No, I can't push. Or I can do push array of the DBI stream of a U32, but for 0 of them. I'm pretty sure that will align. At least that's how I'm always daisy chaining. So yes. Here I align. I think it's fine. And then we have to remember to talk about alignment. So add cleanup. Talk about module alignment in the documentation. Okay. So this now means that the module contribution substream is actually aligned. So we don't have to care about push data aligned or anything. We can just do push struct into the DBI stream of a U32 is the, what was it called? Okay, the version is DIBSC. So let's just say version 1 or something. Section contribution version 1. And now this is where we have to go back to the linker. And essentially, I think I almost have this information. Namely, there are these sections to combine. And in these sections to combine, let's see what they are. There's a section header and an image section header, which essentially says that this image section or this section header, which is in the object file, was mapped to this image section header. But okay, let's see what this section contribution tells me. So it has a section ID, an offset, a size, a characteristic, a module index, and then a data CRC and relog CRC. I don't care about the CRCs. So module index. So essentially, I need the module index tells me which module was responsible for section ID, offset, size, and I guess characteristics. Which I think I can derive that information from this section information thing. So let's try to derive that information from that. And say PDB section contribution section contributions is push data. Where have I been allocating into arena? Let's push array in this code base of these PDB section contributions. And I need linker. It's not amount of object files, but sections to combine. Amount of sections to combine. And then for 332 section index is 0, section index smaller than amount of sections to combine, section index plus plus. We get the section contribution from the section index. This is what we want to fill in. We care about the section ID, we care about the offset, we care about the size, and we care about the module index, and lastly the characteristics. And we are supposed to get that from the sections to combine. Which is a section header. Let's call it object file of section header object section. The object file, which I think we can use through some math to derive the module index. And lastly, conf section header, the image section. And now there's some hack in here, which I'm pretty sure, which allows me to get the offset and okay, let's look at hack. Override the file header here to make sure the file size is whatever. This is really hacky. This is it. We use this useless member to map the object section header to the image section header. Last image section minus image section. Okay. Okay, this just gives me the image section for the object section. It's not too useful. The virtual is the start offset, so that is useful. The virtual address. And the end is the start of the size. So the size of raw data is not the size, but the end. Okay, yeah, that makes sense. But we care about the object section header. Okay, but we have the size as the size of raw data of the object section header. Okay, so we can say the offset is the object section virtual address. The size is the object section size of raw data. Let's make a comment here. This is part of the of a hack. Sure, that's fine. See above. The section ID is the image section. ID, so image section minus where do I have that? Do I have like an image section headers? Image sections. But I think, if I recall correctly, let's scroll down here, this is one based. Yeah, the section ID is one based. The module index, on the other hand, is 0 based, and it is this object file. So object file minus probably object files. Yeah. Lastly, the characteristics. The characteristics field has the same layout as the characteristics field of the section header. Sure. Section header, I say, not segment header. So I'm gonna believe myself. say this is the image section, characteristics. And then in the write PDB information, I'm going to put I guess 264 size t, maybe amount of section contributions, and then section contributions. The amount of section contributions is actually this amount of sections to combine. This might not be 100% correct yet, because I think we would need section contributions for the linker module, which will get complicated, but I'm just going to ignore it for now. Section here we are. So I think then these might have to be sorted, but they might already also be sorted. I'm not sure. So I'm sure that they have to be sorted. But let's mem copy them in for now. So mem copy section contributions comes from, like, let's push struct push array section contribution contributions is push array into the DBI stream of struct PDB section contribution for the where we write PDB information amount of section contributions and copy into this from write PDB information section contributions for the size of one of these section contributions times amount of section contributions. And then we have to do the thing again where at the start we take the substream start and in the end we take the size section contribution and fill that into the header. Very nice. the file name, not a member of this guy, file path. Sure, let's call it file name for now, because that's what we have. PDB section contribution undeclared. That makes sense, because currently we have that somewhere in here. Is it not called that? Oh, I'm in linker. This boy. PDB section contribution. This is now passed in, so it needs to live outside. Section header, spelled wrong. Yeah, there. Okay. So far, so good. Section map substream. Into write PDB again. Where we were filling these out. Section contribution substream. Next up. Section maps substream. This one is sort of useless if I remember correctly. The section map substream starts with the following header: PDB section map header, section map stream header, number of section descriptors, number of logical section descriptors. In practice, both of these are equal to the section count plus 1. The header is followed by an array of 1 plus the section count many entries with the following layout. This table seems to be related to some older object file formats, object module format used by DOS on 16-bit Windows, so good stuff. And then in practice, this table always looks like that. So this being, I think, this was used using cbdump. Notice that each of the section, the cbsec or section size of the virtual size is the virtual size of the corresponding section. According to the LLVM, the flags can be right from the following enum. Which I think I'm just going to leave the flags as 0 and see if that works. Like, this is all complete garbage. No one cares. So I'll pass these in, let's say. No, not these, but I pass in the section headers. I need those later on anyway. So struct image section headers, image section headers, and use 16 amount of image sections. Are we good? Image section headers undeclared? What is it called? Is it just called image sections? Yes. Let's get this definition section map push array into the DBI stream of these section map entries. And we need, how many did it say we needed? We needed 1 plus the section count. The section count we now have in the right PDB information, section count amount of image sections. For 232 section index starts out at 0, section index smaller than amount of image sections, section index plus plus. The section map of the section index sec, which doesn't seem to be one of these, so it's just the frame, is the section index plus 1. The S name, so section name and class name, are minus 1. The offset is 0, so it's only the section size, which it told me is the virtual size of the corresponding section. So image section headers of the section index virtual size. And then the last one, is the same, but the size is OXFF. And so much for the, oh no, wait, I'm missing these two U16s. So push struct into the DBI stream for U16 is the amount of image sections plus 1. And then let's say number of section descriptors, number of logical section descriptors. Now the section map should be beautiful. I don't think I care about the flags, but let's put a cleanup here. OVL group, yeah. Seems this array does not serve any purpose in the current version of the PDB format and is mostly ignored. Yeah. Source information substream. Well, we don't have any source files currently, so this is going to be a little bit boring, I guess, but okay, U16. Oh, I also forgot to fill in the header again. So I need to again start by getting the size, the start. Of the section map substream. In the end, calculate the size. By subtracting where we currently are minus the start. And putting this into the header. So the DBI stream header, byte size of the section map. Map substream is section map substream size. And we need to truncate that again. Source information substream contains the file names of files compiled for each module. It has the following layout. This is going to be a little bit weird because I don't actually know how we would get these from the object files right now, but maybe this is, we are supposed to first parse all the debug S sections and it's somewhere in the debug S sections. I'm going to assume this is true and put a big add incomplete in here. For now, this is stupid. So into the DBI stream, we put an AU16, which is the amount of modules. And the amount of modules is simply the amount of compilation units plus the one special linker module. So amount of object files plus 1. Truncated amount of source files. The truncated amount of source files for now is 0. Then for amount of modules, we have the source file base index per module and the amount of source files per module. Push array into the DBI stream, U16s for amount of modules. So let's get this value out, U16 amount of modules. Which makes this comment obsolete. And now these are all going to be 0. So this is the source file base index per module. And then we have also for amount of modules the amount of source files per module. Then we have the source file name offset in string buffer for amount of source files. Here I'm a little bit weirded out. These are U32s. Is there any alignment requirement? Align to 4 bytes is at the very end. Because at this point it could be non-4 byte aligned. Okay, let's at least say that we have to talk about this in the documentation. So add cleanup source file name offset in string buffer is aligned or not. Document. Then I guess I'm not going to do anything for it. Might be wrong if there's no alignment. And then the string buffer and align to 4 bytes. So aligning to 4 bytes, I can do with push struct again, or push array. And then the string buffer is just a single U8 for now, because there aren't any strings. And we have to do the same thing, where we start out taking the start of the thing. Source information substream. Then we take the source information substream size. And truncate that into the DBI stream header. Server map substream. This is 0, so that's fine. The edit in continue substream has the same layout as the dash name stream. We've already seen its use as the string table stream for the edit in continue source file string index and edit in continue file string index, members of the PDB information structure. Warning, the size of the edit and continue substream is not aligned on any particular boundary. This means that the following substreams is unaligned. Luckily, there's only the optional debug header substream left. We have already stubbed out the /name stream with nothing in it. So, dash names. So my friend, dash name stream, you come with me. The edit and continue substream is a version of the /name stream. Here is a stop. The signature, the hash version, the string buffer size, the string buffer, the zero-sized string, string buffer size, bucket count, buckets, amount of strings. All right. Names stream is now the DBI stream. And that was quick. Let's fill out the DBI header again. Byte size of the edit and continue substring. And lastly, so we can finally be done with this, the optional debug header substream. The optional debug header substream is an array of optional stream indices which contain debug information about the executable. The following entries are currently defined: FPO data, exception data, fix-up data, OMAP data, OMAP from source data, section header dump, that is the only one we care about and which we will fill in, but not today. CLR token to CLR record ID, X data, P data, which maybe we could fill in the X data and the P data section. Section index of the new FPO data and stream index of original section header dump. Okay. But anyway, let's push one of these structures. And then this time we can make this a little bit easier. So the DBI stream header byte size of the debug header substream simply the debug header substream size of the debug header substream. Debug headers. Let's say size of debug headers. And the debug headers is just this, which we push into the DBI stream. And here we have to think about this warning that that this is not aligned to any particular boundary. So this optional debug header substream is unaligned. So we have to use push struct unaligned. And then for now, mem set the debug headers OXFF -1. So all of these stream indices are going to be -1. If they're not present, which we're going to mark every single one not present for the size of the debug headers. Okay, and well, tells us what is maybe supposed to be in these, and then goes on to talk about the next stream. So here we are maybe done. Image section headers. Conf section header, I think it's called. Source information substream size. Byte size of the debug header substream. So debug headers with an S. No. DBI stream header. Optional debug header substream. Forgot the optional, of course. Compile truncation. Section name. Class name need to be casted to U32. U16 maybe. And that's all the warnings or errors. So we can go link. That linked it. And then I want to validate it. And it's probably gonna yell at me. Because we did a lot. A.pdb. It didn't yell at me. DBI stream is empty. That makes sense. In the write PDB, I forgot that right here I need to go the DBI stream is the DBI stream base and the DBI stream size. Error. Debug stream. Oh, that's a good one. The debug header stream does not specify a section table dump stream. For this stream is technically optional but always present and required for the PDB to translate section ID offsets to relative virtual addresses. But it tells me that's the only complaint. So I'm going to take a quick look over everything else. But I guess there isn't much else. Do I not dump anything for anything else? I guess I don't. But I can see the DBI stream looking just fine. The optional debug header is looking just fine. And I guess in validate I don't dump anything else, but it was validated. DBI stream. Let's see what we actually did. Yeah, we dump. Then we get all of these substreams. Oh, I validate the optional debug headers first. That's why it's not dumping anything else. So let's, I guess, add that dump stream very quickly. That should be fast. In write PDB, we need to specify the section header dump stream. And I think we don't actually have to do anything for that, mostly. You can simply say at the very end here, the streams of the section header dump. The data is write PDB information, image section headers, and then the size U8 is amount of image section headers times the size of one of these. That should do that. And then when we initialize these debug headers, I say that the debug headers of the section header dump is PDB stream section header dump. Link, validate. Link, validate. The debug header stream What am I missing? Oh, put it in the wrong place. Initialize all to not present. The first array contained in the source information substream should contain a truncated accumulated amount of source file. This is untrue. For module 1, array specifies 7, but source file base is 0. Not the linker. I want write PDB. So we've probably not made it that far. Amount of source files is 0. That's what we specify. Then for amount of modules, we push U16s, which should be 0 by default. They are zeroed. Then another amount of modules, U16 0. And another 0. So I don't know where it's getting this 7 from. Very suspicious. Array specifies 7, which means I think this is specifying 7. This guy cannot be true either. Maybe let's see what it dumped for those. Did it dump anything for those yet? No. So the debug headers go straight in for the amount of modules 78. It's incorrect. So somehow these offsets are incorrect. But how could they? Module information substream start. byte size of the module information substream. Module information substream size. Or 87 could be true. I don't actually know how many modules there are. Let's maybe set a breakpoint here and see. Debug break. Wait, section contribution substream. Oh, I missed this. This is also before that. The start. Oh, do I have the right order? Maybe I don't have the right order. Amount of section contributions. Oh, I shouldn't use this because you can't see. I have to scroll like this. Maybe if it lets me. Amount of section contributions. Amount of section contributions. So that seems fine. Size of a section contribution. Okay, section contribution substream size. That's where we currently are, minus the section contribution start. Seems fine. Section contribution substream size, sure. All of this seems fine. Section map substream. Oh, there are a lot of substreams before this, I guess. But where I really wanted to go is here. So maybe there's something not aligned which is supposed to be aligned, is my current guess. So db, oh, I see. dbi stream header. And then we care about these sizes, format them as hexadecimal. This is not hexadecimal, pretty sure. Wasn't there a hexadecimal display? This is what I want. 4C. Those seem all fine. Those are all multiples of 4. What's the amount of modules? For E. 87, so it's actually correct. What it told me. It told me there are 87 modules. The amount of modules we put into the first slot, the U16. Then truncated amount of object files. DB. So let's see how this looks. Why is there stuff in there? dot base plus dbi stream dot base plus dbi stream dot current. Is that not how arenas work? Allocated. And I again want to format this as db. So now we can see when it writes out of bounds, because that seemed like what was happening. So in the section next substream, oh, is this last one out of bounds? Yeah, this one's out of bounds, because I only pass in the amount of image sections. So here you can see, right, PDB information, amount of image sections. But there should be one more right here for this guy. And that was in right PDB. Section map. And that looks very nice. All of these modules, you can see they look okay. You can see there is one of these edit and continue substreams, section contributions, seem like a lot of section contributions, but maybe that's how it works. Okay, yeah, source information, substream, doesn't complain about anything. That's great. So that was it for today. Okay, it says the public symbol index stream is too small to contain seller, so there's probably a check for it being -1 not there. But anyway, what I filled in today works perfectly fine. In the next couple ones, we are actually going to attack some of these other streams, like the module symbol streams, I think is going to be next. Then these ones are going to feed into the symbol record stream, the public symbol stream, the global symbol index stream. And those are all the streams left. If we look at the right PDB stream. Right, so the symbol record, global symbol index, public symbol index, and then one module stream per module. Okay. Thank you for watching. And if you enjoyed this, maybe see you again.